A dust storm, also called sandstorm, is a meteorological phenomenon common in arid and semi-arid regions. Dust storms arise when a gust front or other strong wind blows loose sand and dirt from a dry surface. Fine particles are transported by saltation and suspension, a process that moves soil from one place and deposits it in another. Drylands around North Africa and the Arabian Peninsula are the main terrestrial sources of airborne dust. It has been argued that poor management of the Earth's drylands, such as neglecting the fallow system, are increasing dust storm size and frequency from desert margins and changing both the local and global climate, and also impacting local economies. The term sandstorm is used most often in the context of desert dust storms, especially in the Sahara Desert, or places where sand is a more prevalent soil type than dirt or rock. When, in addition to fine particles obscuring visibility, a considerable amount of larger sand particles are blown closer to the surface, the term dust storm is more likely to be used when finer particles are blown long distances, especially when the dust storm affects urban areas. As the force of dust passing over loosely held particles increases, particles of sand first start to vibrate, then to move across the surface in a process called saltation. As they repeatedly strike the ground, they loosen and break off smaller particles of dust which then begin to travel in suspension at wind speeds above that which causes the smallest to suspend. There will be a population of dust grains moving by a range of mechanisms: suspension, saltation and creep. A study from 2008 finds that the initial saltation of sand particles induces a static electric field by friction. Saltating sand acquires a negative charge relative to the ground, which in turn loosens more sand particles, which then begin saltating. This process has been found to double the number of particles predicted by previous theories. Particles become loosely held mainly due to a prolonged drought or arid conditions and high wind speeds. Gust fronts may be produced by the outflow of rain-cooled air from an intense thunderstorm. Or, the wind gusts may be produced by a dry cold front. That is, a cold front that is moving into a dry air mass and is producing no precipitation. The type of dust storm which was common during the Dust Bowl years in the US following the passage of a dry cold front. Convective instability resulting from cooler air riding over heated ground can maintain the dust storm initiated at the front. In desert areas, dust and sandstorms are most commonly caused by either thunderstorm outflows or by strong pressure gradients which cause an increase in wind velocity over a wide area. The vertical extent of the dust or sand that is raised is largely determined by the stability of the atmosphere above the ground as well as by the weight of the particulates. In some cases, dust and sand may be confined to a relatively shallow layer by a low-lying temperature inversion. In other instances, dust may be lifted as high as 20,000 feet high. Drought and wind contribute to the emergence of dust storms, as do poor farming and grazing practices by exposing the dust and sand to the wind. One poor farming practice which contributes to dust storms is dryland farming. Particularly poor dryland farming techniques are intensive tillage or not having established crops, or cover crops when storms strike at particularly vulnerable times prior to revegetation. In a semi-arid climate, these practices increase susceptibility to dust storms. However, soil conservation practices may be implemented to control wind erosion. A sandstorm can transport and carry large volumes of sand unexpectedly. Dust storms can carry large amounts of dust, with the leading edge being composed of a wall of thick dust as much as 1.6 kilometers is a sandstorm. Prevalent in the region of Sudan around Khartoum, with occurrences being most common in the summer. The Sahara Desert is a key source of dust storms, particularly the Baudelaire Depression and an area covering the confluence of Mauritania, Mali, and Algeria. Sahara dust is frequently emitted into the Mediterranean atmosphere and transported by the winds, sometimes as far north as Central Europe and Great Britain. Saharan dust storms have increased approximately tenfold during the half-century since the 1950s, causing topsoil loss in Niger, Chad, northern Nigeria, and Burkina Faso. In Mauritania there were just 2 dust storms a year in the early 1960s. But there are about 80 a year today, according to Andrew Gaudy, a professor of geography at Oxford University. Levels of Saharan dust coming off the east coast of Africa in June 2007 were 5 times those observed in June 2006, and were the highest observed since at least 1999, which may have cooled Atlantic waters enough to slightly reduce hurricane activity in late 2007. Dust storms have also been shown to increase the spread of disease.